Okay, good morning, everybody. Am I audible? सुनाई दे रहा है मेरे बात?
Yes, sir.
We will wait for 2 to 3 minutes so that rest of the student could join, and then we will start the class. Okay, so let us start today's class because I think that this much only students will come today. Last day we have started representation of discrete time signal as summation of impulses, and in that we saw how we started, and we write, if we multiply the signal with some delayed input impulse, then the product of the signal will be a non-zero, and only at n equals to m and 0 for all values of n. Also at n equals to m, the value of product signal is ms sample of xm of the signal xn, and we have proved that. So pre-capitulation, if I start with the last day's plan or last day's topic. So just a minute. Just a minute. If you take to the last day's class, we go to the 11th. Just a second. Yes, you can see here. What we take a representation of BT signal as summation of impulse. The screen is shared. Can you see
Yes,
that?
sir.
So you can see here Xn is equal to the BT signal and delta n is the unit impulse signal and delta n in n minus m is the delayed impulse signal. So as per the definition, delta n equals to 1 at n equals to 0 and equals to 0 when n is not equals to 0, and delta n minus m equals to 1 at n equals to m and 0 when n is not equals to m. So if we multiply the signal xn with the delayed impulse delta n minus m, then the product is non-zero only at n equals to m and 0 for all others values. So if I draw the signal, if I show you the signal, you will see that at if delta n minus m, what is delta n minus m? That means delta n equals to 1 for m equals to 0, and at n equals to m, there is a non-zero value, and 0 for others values. So also at n equals to m, the value of the product signal is the ms sample of xm of the signal xn. That can be told. Clear? Because at n equals to n equals to m, let us suppose, let us do the calculation by taking n equals to 1. So at x of 1, delta n minus 1. So at n equals to 1, I get the value. So n equals to 1, I get the value of 1. Rest of all, there is a 0 value. So x of n, that is something value, into 1 will be the same value. Understand? If I multiply something by 1 all the time, that will give us the value of the same. So at n equals to 1, what is the value of xn? That will be highlighted. So the product signal is the image sample of the xm of the signal xn. Clear?
Yes, sir.
Okay. So after that, let us develop the next part. So today is our 17/1/2022. So each multiplication of the signal x of n by an unit impulse at same delay m in essence picks out the single value xm of the signal x of n at n equals to m, where unit impulse is non-zero. So consequently, if we repeat the multiplication on all possible delays in the range of minus infinity, m lies in between minus infinity to plus infinity, and add the product sequences, the result will be sequence that is equals to the sequence of xn. Example that x of n delta n minus 2. That is x of minus 2. Likewise, x of n into delta n minus 1. So that is equals to x of minus 1. Same as x of n into delta n minus 0. That is x of 0. Same x of n into delta n minus 1. That is x of 1. Same x of n into delta n minus 2. That is x of 2. So from the above products, we can say that each example of xn can be expressed as a product of the sample and the delayed impulse. Understand what I'm telling?
Yes.
Like this we have done this. It is giving the value of the product. So from the above products, we can say that each example of xn or each sample of xn can be represented or expressed as the product of the sample and the delayed impulse. Please mute your phone. Okay. So we can write here from here. If we can write, let us see this very important. If you understand this, it will be applicable for you because this needs understanding. So we can write what we can write x of n. How x of n can be introduced? It can be introduced dot, 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 dot. I don't know previously how many terms are there. Then we can write x of minus 2, then plus of x of minus 1, then plus of x of 0, then plus of x of 1, then plus of x of 2, then plus of x of 3. Like this again, I don't know because it is going from minus infinity to plus infinity, so I don't know. So how can we represent this? We can represent this as per these products. So we can represent like this, because that also gives you the same thing, that x of minus 2 equals to delta n minus minus 2. That is also same meaning, plus x of minus 1 into delta n minus minus 1 plus x of 0 into delta n minus 0 plus x of 1 into delta n minus 1 plus x of 2 into delta n minus 2. So like this we can represent. So that gives us generalized, we can write, that is equals to summation of m equals to minus infinity to plus infinity x of m into delta n minus m. So this is the equation. So in equation number 1, each product xm into delta n minus m is an impulse, and the summation of the impulse gives the sequence xm. So that we can represent a discrete time signal as a summation of impulse. Understand? ये क्या है? ये है एक सीक्वेंस. तो इस सीक्वेंस को हम कैसे रिप्रेजेंट कर रहे हैं? ये रिप्रेजेंट कर रहे हैं समेशन ऑफ इंपल्स से, क्योंकि इन दोनों का प्रोडक्ट क्या होगा? एक सिग्नल है, सीक्वेंस है, उसके साथ डिलेड इंपल्स प्रोडक्ट कर रहे हैं, तो वो भी एक इंपल्स होगा. तो इन दोनों का प्रोडक्ट से आपको एक सीक्वेंस मिल रहा है. तो हम लोग क्या बोल सकते हैं? हम लोग बोल सकते हैं कि डिस्क्रीट टाइम सिग्नल को हम लोग समेशन ऑफ इंपल्स से रिप्रेजेंट कर सकते हैं. Understand? Everybody?
Yes, sir.
This is very
सर
important.
समेशन में सर xn होगा या xm होगा?
XM होगा. n तो डेल्टा n माइनस 1 डिले कर रहा है, तो XM होगा. ठीक है?
Yes.
जितना देखो, जितना डिले कर रहा है उतना यूनिट हो रहा है. ये देखो, यहाँ पर -1 है, तो यहाँ पर माइनस है. n तो फिक्स्ड है, तो m का वैल्यू चेंज हो रहा है. यहाँ पर m का वैल्यू चेंज, कभी -1 हो रहा है, तो कभी यहाँ पर -1 हो. ठीक है? So that is the first thing, representation of a discrete time signal. Just a minute. So let's just go to the next page. Response of LTI discrete time system using discrete convolution. So let us see how can we do it. So in a LTI system, the response Yn of the system for an arbitrary input Xn is given by convolution of the input Xn with impulse response Hn of the system. So it can be represented as Y of n equals to X of n convoluted with H of n. That gives the formula summation of n m equals to minus infinity to plus infinity x of m into h of n minus m. So let us take this equation number 1. So where the symbol represent the convolution operator, this symbol is convolution operator. Okay. So if I want to prove this statement, what I will do? Let us prove this statement. So let Yn be the response of the system H for an input Xn. So that is equals to Y of n equals to H of X of n. So from equation 1, we know that KNOW know that the signal Xn can be this is equation number 2. Expressed as a summation of impulse so that is we can write Xn equals to summation of n equals to minus infinity to plus infinity x of m into delta n minus m. So this is n. Where delta n minus m is the delayed signal. So let us take this equation number 3. And let us give this equation number 4. So from equation 3 and 4, we get what we get? Y of n can be written as h of summation of m equals to minus infinity to plus infinity x of m into delta n minus m. This is equation number 5. So the system H is a function of n and not a function of m and not a function of m. Hence, by linearity property, we can write what we can write by linearity property. Anybody? So this is very ridiculous. I already asked you what you are understanding or not, what you are telling or not. We are doing the equation, but what is happening? You are not answering. You are not responsive. I don't know why. Why are not you responsive? बस अभी अगर तुम लोग को बोलता हूं तो तुम लोग निकल जाते हो क्लासरूम से. तो जो आप लोग बोल सकते हो कि लिनियरिटी प्रॉपर्टी यूज करने से क्या होगा. सभी का माइक नहीं ऑन हो रहा है एक साथ. Okay, I don't know what is going on. So we can write y of n can be written as summation of m equals to minus infinity to plus infinity x of m into h of delta n minus m. So this is equation number 5. Okay. So let the response of the LTI system to the unit impulse input delta n be denoted by Hn. So that can be written as Hn equals to x of h of delta n. H of delta n. So then by type invariance property the response of the system to the delayed input impulse is given by h of n minus m can be represented as h of delta n minus m. That is 5 to 6. So using equation five and 6 can be expressed as y of n is equal to summation of m equals to minus infinity to plus infinity x of m into yes, h of n minus m. So from the above equation, we can represent the convolution of the input xn with the impulse response hn to yield the output y of n. Hence, it is proved that the response y of n of an LTI discrete time system for an arbitrary input xn is given by the convolution of the input xn with impulse response hn of the system. So I think everybody has been clear. So
Yes, sir.
okay. So there is not much time left. Please, everybody, give your attendance in the chat box. Without the attendance, I cannot give you first class attendance. Okay. So write your name in the chat box, everybody. So I will give you 2 minutes. Okay. Everybody, I just get 3 students. Okay, so everybody has given the attendance, but I am seeing 9 students have given and 10 students are there. Okay. So up to this, anybody has any confusion? So no answer, so I don't think any confusion is there. So next day we will start interconnections of discrete time system. There are 2 types of interconnection in discrete time system. One is called the cascade connection and it's called as parallel connection. And we will discuss about this connection and how to realize a discrete time system. That will be discussed there. Okay. So anybody, any confusion about these chapters? Any question on the topics? Okay, so thank you. So thank you for joining the class. Hope this will be, we will join in the next class and we will discuss about the interconnection of discrete time system. So you can leave. Thank you for joining this class. Have a good day.